Okay, we good? Okay. Okay, so as you can see, this is a talk about Perl caching and memory leaks. There's a couple of caveats. The first is that this is quite high level, and there are several people in the audience that know the internals of Perl far more intimately than I do, so this might be a bit hand-wavy in parts. They can heckle me later. My C is also very rusty. Although if you read Hacker News, people seem to want Rust these days. It's kind of the obvious joke. And this is kind of just the basics. I know these slides are a bit, if you're more than 5 rows back, you might have to struggle to see the bottom. So if you go to lejo.github.io/code, you can actually see this presentation. So I'll just give you a few seconds to type that in if you need to. Okay. Ovid actually mentioned this in his presentation. We've all heard of this: make it work, make it right, make it fast. And the oft missed additional clause is fix all the big bugs you introduce by making it fast. And one of the ways we make things fast is by using caches. And if you have enough of these, you might end up with memory leaks or other issues. More on this later. First, a little recap. I say spot the bug, but I'm not going to ask you to spot the bug because this is a talk about memory leaks, so it should be fairly obvious what the bug is. I've got a for loop there that mallocs but never frees, so we have a memory leak. And the process size doubles. We have to deal with this in C. We just call free. It's not a problem in this trivial example because it's a script that runs a loop and exits. It doesn't sit there. But if you imagine this is deep somewhere down in a library somewhere, you call it a few times, you call it a few million times, then you've got a memory leak. And that's why we have tools like the address sanitizer, purify, valgrind in C. We can find these. How about in Perl? Well, this isn't exactly the same, but it's good enough for the example. Pretty much doing the same thing, running a for loop, and then printing the memory use. And it doesn't grow in Perl. Well, it grows a little bit because it has to assign some memory at first, but because of the scope of the loop, Perl knows the variable goes out of scope, we can reuse the memory. And we don't really have to worry about this so much in Perl until we do. And memory is cheap, but it's not infinite, or at least not infinitely fast. I mean, you can add more swap, but that's not going to be quick enough, basically. And just some more of the basics. If you look at the Perl doc for Perl guts, it tells you how Perl handles the memory, how it does the garbage collection, and it does a reference counting garbage collection. And we can actually inspect reference counts by using the devel peek cPanel module. So if we actually dump out that variable, we get this kind of nice structure. I'm not going to go through it here. I'm just going to highlight the reference counts. Now, as you can see, this is kind of a nested structure, so it's self-evident that the things nested on the things above it are referenced by the things above it. And as you can see, we just have a single reference count on each of those variables. So when the top one goes out of the scope, Perl knows the rest are no longer referenced. We can reuse that memory. So here's that same Perl script with a very subtle tweak. I've actually create a global variable, and I'm now pushing a reference to that array onto the global variable, and yeah, we have a problem. 3 unibit gigabytes. And if we dump that structure out, which you probably don't want to do because it's 3.2 gigabytes, so I kind of cheated a little bit. Can you see the difference there? It's now 2, so we've got something else that's referencing that. It's not just the one above, it's somewhere else we have a reference to it. So the reference count here, apart from when obviously the process exits, the ref count doesn't ever go to 0, so something's holding on to that memory, and Perl doesn't know that we can reuse it because it thinks we're using it forever. Okay, so just a little bit about our app. This is a typical page on the site. So we're running a Mojo for the framework. We're using Template Toolkit for the templates. We're using Moose for the objects. And what we do is we pass those Moose objects into the templates. And we try to do as much as possible with objects because they're just nice to work with. They provide proper encapsulation and abstraction. And what we do is we break out the repeated code into roles. And this even includes constructor logic. So for example, on our site, we are a crowdfunding platform, and we have the concept of an activist, which is kind of a fundraiser. And what we do is, in the activist class, instead of having all the logic in the new method, we have actually a populate activist, which knows how to take a Divic class result set object and create a new activist object. And the reason we do that is because we call it, activist is fundamental to our platform, so we call it everywhere. We're creating activist objects everywhere. And we don't want to repeat the code everywhere. Even the calling, activist new, we don't want to then have to pass all the attributes in. We just want that in one place, and it's in a role. So there it is in some other class. It's essentially doing the same thing. And we are very, very greedy with the data. We try to grab as much as possible from the database. We're using a lot of prefetch in Divic, and we try to populate as many objects as necessary ahead of time. So an activist isn't just an activist. They also have a country and a currency and all these kind of associated objects. Yeah, and we're greedy because going over the network to the DB is very expensive. That's generally where your bottlenecks are these days. If you think about it, you're running on servers with lots of memory, the SSDs, the database server is the same, it's using SQL caches, and the bottleneck for us generally is reaching over to the database and grabbing that data. We're not running huge data sets, we're not running tight algorithms. So the network is the database for us. And doing several joins is cheaper than doing several single queries, because once and back again is obviously a lot cheaper than several times. So this is another page on our app. This is a list of donations to a charity. And all the blue dots here are basically built from objects. And we can, on a page, we can end up with the same object more than once, because an activist can donate to a cause more than once. We have the same currency object more than once, the same country object more than once. And I realized that we could trivially optimize that, because the first thing you do in optimization is remove duplicate work. So what I created is this. In lieu of not knowing what really to call it, I called it the ephemeral object cache. And those populate methods that I talked about, the things that build the activist objects, the things that build the country objects, they have this globally scoped cache, basically a global variable. If the object already exists for that class, return the object. And now the objects, obviously, they're not singletons. They're keyed on the primary key of the record in the database. Like I say, they're sort of like singletons, but not. I don't know what the general term for this would be. And the important thing, obviously, is the cache only persists for the life of the request. We nuke the entire cache at the start and the end of the request, the web request, to make sure we're not, again, creating a memory leak at a distance. And it turns out this can be quite a big optimization on some pages. So we have this debug in our logs, which tells me how many objects we created, how many we actually reused. And on some pages, it can be an enormous optimization, because our platform is very flexible, and people that use it tend to try to bend it enough to break it. So we, 3,000 objects, but we reuse 3,000 of them. So it's a huge optimization. So this is the activist object, and you can see that's my ID in the system. So yeah, it's quite easy to create an object, call it on the command line, and find out that my name is Lee, which is quite useful. And some of the attributes on these objects are other objects. So we have a donations collection and a donation object. So you can see that my first donation was 100 something. I haven't put the currency in there, but it's there somewhere. But of course, sometimes we want to go the other way around. We have a donation, we want to find who the activist is, so we have a donor method and that we can get the activist. And we can go round and round and round and round, which is a bit contrived, but for obvious reasons. We don't actually have a memory leak here because, as you can see, we have, well, you might not be able to see that at the back, but I printed out the address of these objects and they're different, basically different instances of these objects. Now, if I turn on the ephemeral object cache, we get the same objects because we're using the cache. The problem is now, I have an activist that points to a donation which points back to the same activist. I have a circular reference. And when we have a circular reference, the reference count can never go back down to 0. Perl can't reclaim that memory. We have a memory leak. That's using devel cycle, which is a useful cPanel module by Lincoln for finding these reference cycles. More on this in a bit. So detecting leaks. The problem is if you, in the case of pathological cases where somebody uploads a 200 megabyte XML file and it explodes into an XML simple, those are quite easy to detect because the entire server comes crashing down instantly. If you have a large app and you've got a very subtle leak somewhere, it can be quite difficult to find the source of that leak. So one of the things I did is, when I first joined the company, I wrote one of these high-level integration tests that Ovid actually mentioned as well. So it just goes through the site and finds all the pages. Do we have any 404s? Do we have any missing translations? And it was quite trivial to actually get that to print out the process size, the memory size after each request. And the theory is, if you run this enough times, eventually you're going to have filled all your caches and saturated all your possible objects, and it will eventually plateau. It's not going to grow anymore. If it keeps growing forever more, then you've got a leak somewhere. And the useful thing is here, it tells you what page is essentially leaking. So we've got the entire app and we've kind of isolated it down to at least a root. You can also do brute force dumping. This was recently posted to the London PM mailing list. So you can attach GDB to the Perl process and basically dump everything out. And then you can use a few tools, just grep, and look for multiple instances of the same string in this case. This example, it was just basically NetSSLEA was creating the same instance of something millions of times, and it was quite trivial to find that once you dumped out the data. The fix there was easy, just upgrading the cPanel module did it. Another way to detect the leaks is kind of a brute force destruction with devel cycle. Now, one of the roles we have is a DB role. Everything uses a DB role to connect to the database. So what I did is I added a demolish method to that role. And what I do is just call devel cycles find cycle when the object is destroyed. And that will print out a memory cycle into the logs. It shows us where the memory leak is. But the catch-22 there is that the objects with circular references won't be destroyed. So what you do is you can either periodically restart your dev server and these will get flushed out and you'll get loads of these in the logs, or if you're running a test, the objects will get destroyed at the end of the process, so you see it there. So how do you fix those leaks? Well, the classic example is to use scalar utils weaken method. It's kind of a sledgehammer approach. It prevents a reference count being held against the thing referenced. And this can lead to subtle bugs. So Moose, you can actually say the attributes are weak, which is basically using, I guess, scalar util under the hood. The problem is you get load ordering issues and the thing might go out of scope according to Perl before it's actually started to be used. And Ricardo wrote quite a useful blog post on using weakref with Moose attributes, which lists some of the gotchas and how you have to be careful using it. So yeah, one way we actually fix these is basically to turn those Moose attributes into plain old scalars. It's a bit of a hacky way to do it, but in this case, it turns out that using the cache is more advantageous than having these Moose attributes, because some of the attributes we're not really using the type checking too much, and it's basically finding a balance between not having a leak and having things fast, and then having the type checking. So yeah, we want to obviously prevent regressions. This is kind of the brute force method of doing it, but you really want something more targeted than using a demolish method, because if you're having to watch the logs to get that cycle, you're going to miss those. There is a test version of devel cycle, which is test memory cycle. You can just call memory cycle OK on your object, and it will try and find any cycles, and then the test will fail. So that's the example of the output there, and it does actually tell you where it's failing, so it's useful stuff. There is a test leak trace, which is very, very thorough. It takes quite a while to run. I forget how long this test would run in a couple of seconds with the fixtures it was building, and to use it with test leak trace, it would take a couple of minutes. So it's not something you really want to be running on your CI server. It's maybe something you run before a merge or something like that. And it dumps out. It's a bit more specific than devel cycle. It tells you, it gives you the actual lines of code that it thinks are leaking, so it's much more targeted. The problem with using test leak trace is, like I said, it's very, very thorough. It will find leaks, probably not in your own code, but in somebody else's code, which often doesn't matter. If you think about tests run and exit, so a memory leak doesn't matter. And the test namespace has lots of code that leaks because there's no gain from fixing the code to be, non-memory leaking. And it's found leaks in some of the other cPanel modules we're using. So when I use test leak trace, I have to be very careful about if I'm putting it into a test that I'm only testing our code. And often you're not just testing your code because you're using cPanel modules, but it's very thorough and it's very, very useful. And that's about it. I added a few links there. As I said, there's a lot of people that put a lot more time into this than I have. And there's quite a few useful cPanel modules that I haven't mentioned here for doing more profiling of memory and discovering memory issues. Any questions? Yep. So that's where you can find this presentation, which has all the links to the other cPanel modules. And if you search GitHub Lijo, you will get the raw presentation on GitHub. Yep. Well, I think, is there a page? So the question is there a page on, I guess, the conference website to get to people's slides? Yeah. No, there is. When you create a talk on ACT, there is a link to put in your own slides. And a lot of people won't upload those slides until after they've given the talk. So you should expect most talks to be linked to. This talk is already there. It's been up there, so you can go and look at it now. Nick?
Yes, any question? I think you might use the time to fill in. I haven't used the devel cycle, but I assume it's going around through Perl references. We managed to create a leak of work with Perl, which won't actually use the looking for it.
Yeah, we killed it.
We had a real subtle one where it basically goes through XS. So we had a state object that had a reference to the Apache request object, and then we passed a closure to a cleanup handler. And now we've got a cycle that goes through the Apache XS components. And one of my colleagues fortunately was faster than me to actually find this one, but that was a closure that this approach won't find.
Okay, yeah, so
Yeah,
Nick was talking about a cycle in mod Perl, so basically XS code, and devel cycle. I think it's a pretty It's a pretty high-level approach. It's not digging way down. Whereas test leak trace is actually a much more thorough. I actually ended up with co-maint of that because I fixed the dot in ink bug, and it's about about 10,000 lines of excess code. So yeah, I know. Yeah. Any more questions? No? Okay. Thank you very much.